In this section, 11.3, we're going to be talking about how to use the quadratic formula to figure out how many and what type of solutions we're going to have. We talked about quadratic formula in the last section, right? Hopefully you've memorized it by now. Well, we can actually use that quadratic formula and use the number underneath that radical. It's called the discriminant, that b squared minus 4ac. That number helps us figure out how many and what type of solution we're going to have. If you think about that number, if that number underneath your radical, that discriminant, is 0, then if I have that, it would look something like this. X equals 6 plus or minus the square root of 0 over 2. Well, what's the square root of 0? 0, right? And so I have 6 plus 0 over 2 and 6 minus 0 over 2, which both end up being 6 over 2, which is just 3. So if that number underneath, the discriminant, is the number 0, then I know there's going to be one repeated solution that's rational. If that number underneath is a positive number, for example, 25, I could have 7 plus or minus the square root of 25 over 6. Well, we know if that number is an even square root, we can break it out of the radical and really say that we have 7 plus 5 over 6 and 7 minus 5 over 6. I end up getting two different solutions that are both rational. Now, if that number underneath the radical is not an even root, or I can't break it down evenly, and I'm left with a radical, for example, 3 plus or minus 2 rad 7 over 4, I still get two answers. They're just going to be two irrational answers, right? They're going to be decimals that go on forever if I put it in my calculator. So if my discriminant is 0, I have one solution. If my discriminant is positive, I have two solutions. Sometimes they're rational, sometimes irrational. And if my discriminant is negative, well, what happens if the number underneath my radical is negative? Well, remember, if the number underneath your radical is negative, you can take that out and it would actually be an imaginary solution. It's still two solutions, but they're two imaginary solutions. So we should be able to tell just by looking at the number underneath, the discriminant, how many and what type of solution we're going to have. Let's do a few. If you look at example number 1, it says for each question or equation, determine what type of solution and how many solutions exist. So we don't actually have to solve the whole entire thing. It doesn't actually ask us what the solutions are. It just wants us to tell how many solutions we're going to have. So let's not factor, let's not complete the square, and let's not even use the whole entire quadratic formula. Let's just look at the part underneath the radical, and that'll tell us how many solutions we would have if we were going to solve it. So let's pick out first our a, our b, and our c, and let's just look at that b squared minus 4ac, the discriminant. Make sure your equation is in order and all to the same side, in standard form, which it looks like all three of these are. Now let's look at our a, our b, and our c. For the first one, a is 1, b is negative 5, and c is 3. Remember, let's just look at the stuff underneath the radical in our quadratic equation, our discriminant. That's our b squared minus 4ac. b is negative 5, so let's plug that in. A is 1, C is 3, so my discriminant looks something like this. If I were to simplify, negative 5 squared is 25, and 4 times 1 times 3 is 12, and there's one negative, so I have a negative 12. So underneath that radical, I'd have a 25 minus 12, or I'd have a 13. This would be the number underneath my radical. This is my discriminant, 13. If the number underneath my radical is a positive 13, well, 13 is not an even square root, is it? But it's still positive, so it's still okay. So that means I'm going to have two real solutions that happen to just be irrational. Irrational just meaning that they're going to be a long decimal that keeps going, not a fraction that can be simplified. All right, what about b? Let's pick out our a, our b, and our c on this one. Our a is 1, our b is negative 2, and our c is 4. Let's figure out how many solutions we're going to have here. If I plug it into my discriminant, I have negative 2 squared minus 4 times 1 times 4. When I simplify, I have 4 minus 16, which is a negative 12. So my discriminant value is negative 12. That's going to be the number underneath my radical if I did the quadratic formula. Now what happens if you have a negative underneath your radical? Now we have imaginary solutions, right? There's still two solutions, but they're two imaginary solutions. All right, last one. Let's pick out A, B, and C. I got 4 for A, negative 12 for B, and 9 for C. If I plug these values into my discriminant, I end up getting negative 12 squared minus 4 times 9, which is 144 minus 144, which happens to be 0. So if my discriminant is 0, if I have a 0 underneath my square root, well, the square root of 0 is 0, and that whole chunk kind of goes away, doesn't it? And so I end up with one real or one rational solution. There's no more radical, and then there's just one solution. It's repeated, maybe twice, but it's the same exact solution. So one solution. Discriminants can also be used to determine the number of x-intercepts of a graph, right? So if I can figure out how many solutions there are, I can figure out how many times it touches the x-axis. So it can touch it twice, it can touch it once, or maybe it doesn't touch it at all.